Today we are walking through the paper titled Revisiting on Policy Distillation Empirical Failure Modes and Simple Fixes.
Can we start with the big picture?
This paper revisits on policy distillation for long horizon LLM post-training. The authors argue that sample token OPD is attractive because it keeps token level updates cheap and practical. But it becomes brittle once the student generates prefixes the teacher would not normally visit.
What exactly breaks in practice?
They isolate three concrete failure modes. First, one sample token gives a highly imbalanced learning signal. Second, teacher guidance gets noisy on student-generated prefixes later in the rollout. Third, tokenizer and special token mismatches can punish outputs that are semantically fine.
If one token supervision is the problem, why not switch fully to a sequence-level objective?
Because the paper says that trade-off is real. Sequence-level reverse scale is less biased, but it couples each token update to many future rewards. So the variance grows much faster with sequence length. In long horizon settings, that higher variance can make optimization unstable.
Do they show that instability directly?
Yes. In the toy study, pushing gamma toward the sequence level limit increases gradient variance in both tasks. The point is not that the toy setup is the final benchmark. It is that stronger reward coupling already makes the optimization signal noisier in a controlled setting.
And the state visitation panel shows the same story.
It does. When gamma reaches 1, the policy drifts instead of moving cleanly toward the target. So the paper uses the toy experiment to argue that more future reward coupling may look principled, but it can destabilize the learning dynamics.
So what is the paper's replacement for one token supervision?
The core proposal is teacher top K local support matching. At each prefix, the student is not judged on just the sampled token. Instead, the teacher defines a local support set of plausible next tokens, and the loss compares the student and teacher distributions over that set.
What should I read first in the core equation?
Start with the support set itself. This equation defines the teacher top K candidates at a given prefix. The paper introduces its O supervision stays local to plausible next tokens instead of collapsing to a single sampled choice.
Why does that help more than simply averaging more sampled tokens?
Because the update becomes balanced inside the teacher-supported region. Positive and negative adjustments are redistributed across several plausible continuations, which is much closer to a local reverse scale comparison and much less brittle than rewarding or punishing one sample.
What other stabilization choices turned out to matter?
The practical choices are central. They renormalize teacher and student mass inside the truncated support, and they use stop-B rollout sampling so the student stays closer to typical continuations. They also mask problematic special tokens when tokenization conventions do not line up. Now let us look at the probability scatter between student and teacher tokens.
What pattern matters most in this scatter?
Most sampled tokens sit in the penalty region, while the positive learning signal is concentrated in a much smaller set. So the baseline is not really teaching the whole local distribution. It is mostly telling the student that its current sampled token is wrong. Now let us look at the repetition loop case.
Why is this example important and not just anecdotal?
Because it shows the teacher can stay locally aligned with obviously bad behavior. The student loops, but the teacher still assigns those repeated tokens enough probability that one token rewards fail to push back. That is exactly the kind of misleading supervision the method is trying to remove. This next chart tracks how the teacher-student gap changes later in the rollout.
What does the widening distribution tell us?
Later token positions show wider and more extreme gaps, which means the teacher signal gets noisier precisely where long horizon distillation is hardest. That gives a concrete explanation for why the baseline becomes fragile as rollouts grow. And this final failure mode visual is about tokenizer mismatch.
What is the practical problem in this example?
The same semantic marker can be split differently by student and teacher tokenizer S. If the loss only inspects one sampled token, it can punish a semantically correct continuation, just because the boundaries do not line up. That is why special token masking helps, even though it is only one piece of the full fix.
After all of those fixes, where do the benchmark gains show up?
On single task math reasoning, sampled token OPD raises the average score from 28 point to 236.4, but local support matching reaches 41.5. Even after adding masking to the baseline, the method still stays ahead at 41.5 versus 40.7, which shows the gain is not only a tokenization cleanup story.
What about the harder multitask setting?
There the gains show up mainly on the math side while Elf World stays strong. The unmasked method improves math 500 from 76.0 to 82.0 and average math from 36.6 to 41.7 while remaining competitive on Elf World. The masked version gets the best Elf World score at 97.7, but gives back some of the math improvement.
So what should I remember as the paper's main claim?
Keep the token level stability of on-policy distillation, But stop pretending one sampled token is enough supervision. By matching teacher and student over a teacher-selected local support, the method gives a more balanced signal and produces better optimization behavior and better downstream performance in the settings. The paper test.
And what limitation do the authors leave open?
They are careful not to oversell it. The objective is still a truncated surrogate rather than full distribution matching. The reward hacking story is supported evidence rather than a complete causal proof. And teacher matching is still only a proxy for true task success.
So the win is a better local teaching signal, not a completely different post-training recipe.
Exactly. This paper keeps the practical token level setup, replaces brittle one-token supervision with local support matching, and shows concrete gains in both optimization behavior and downstream performance. That wraps up this paper walkthrough.